what the cross product meant with regards to its physical significance. Then the area of the triangle is given by half into A vector cross B vector. So if you have three vectors here, this is A vector, B vector and C vector, all of them, because cos alpha, this alpha is the angle between this C vector and A vector cross B vector. Why? You see over here it says A cross B dot C is equal to A dot B cross C. Why? Hi students, welcome to this session here at Infinity Learn by Sri Chaitanya. Today we are going to take a quick take, we are doing a quick take on the scalar triple product. This comes right after your scalar dot product and scalar cross product and actually combines both of them together to give you a very necessary quantity with regards to physics and also with regards to maths. So let's see what that is. Before we get started off with the scalar triple product, let's quickly revise what the cross product meant with regards to its physical significance. So if you have two vectors A and B being the sides of a triangle, then the area of the triangle is given by half into A vector cross B vector. So the magnitude of A vector cross B vector, take half of that and you get it. Similarly, if you want for a parallelogram, it's just 2 times of this, which means it's just A vector cross B vector. Because if you understand, if this is your A vector and this right here is your B vector, then you can effectively create a triangle like this whose area would be given by half into A vector cross B vector, or you can replicate this B over here, making a B and replicate the A over here, then you get a parallelogram. And the area of the parallelogram is A vector cross B vector. And you can see why this is twice of the area of a triangle, because it's just this triangle and a similar triangle arranged opposite over there. So the area of the parallelogram is just the area of 2 triangles. Now we've got basic introduction to that. Now we move on to the scalar triple product. So scalar triple product is represented as this over here in between these third braces, A, B and C, where the scalar triple product is A vector cross B vector. You effectively get a vector from this. This is going to be a vector, and you take the dot product of that resultant vector with the third vector C. So the last thing you're doing is a dot product, which means the effective thing that you're going to get out is going to be a scalar value, because you're getting a dot product out. So the resultant is always a scalar quantity. Cross product of the vectors is calculated first, followed by the dot product, which gives the scalar triple product. Alright. Now let's understand what this gives us. The scalar triple product gives you the volume of the whatever parallelepiped your 3 vectors are creating. So if you have 3 vectors here, this is A vector, B vector and C vector, all of them are connected at one point, then they will create a parallelepiped. And the scalar triple product is going to give you the volume of this parallelepiped. Let's understand again how that comes about. First, A vector cross B vector, that is going to give you the area of this piece. A vector cross B vector gives you the area of this base, right? Because that's the area of the parallelogram. Then in order to find the volume of this, you need to multiply this base area with this height over here. Not this angle, because this is an angular length. You need this height over here. Now if this vector is C, then this height would be C cos alpha. The height is C cos alpha. So the parallelepiped will have a volume of A vector cross B vector, which is the base area, multiplied with C cos alpha, which is this height over here, which effectively makes this as A vector cross B vector dot C, because cos alpha, this alpha is the angle between this C vector and A vector cross B vector. Why? Because A vector cross B vector will give you the product will always point by the right hand thumb rule in the upward direction, in this direction. It's always perpendicular to A vector and B vector. And this alpha is just the angle between C and A vector cross B vector. That is why when you take that vector, next vector and cos alpha, that effectively means you're taking the dot product of both of them. That is why this relation gives you the scalar triple product, which is the volume of the parallelepiped. Okay, let's switch back to yellow. So over here, if it's been given in I cap, J cap, K cap notation, there's two ways to go about it. First, you find this cross product using this relation, you get a vector, then take the dot product where you'll multiply the I caps, multiply the J caps, multiply the K caps and add them all together. Or you can shorten this process up by directly going, forget the I cap, J cap, K cap, just put C1, C2, C3. The corresponding I cap, J cap, K cap of whatever you're finding the dot product with, to have it in this form where A1, A2, A3, B1, B2, B3 are in the same place. Just the I cap, J cap, K cap has been replaced by this. Then you solve as you would normally. Normally what did you do? You took I cap A2, B3 minus A3, B2. Same thing you'll do here. C1 into A2, B3 minus A3, B2. Similarly, minus C2 into A1, B3 minus A3, B1. So on. Okay, if you have already gone into class 12 and then you're watching this, you already are familiar with determinants and how to get the value of the determinants out. Is that exact same thing over here. Next up, if the vectors are cyclically permutated, okay, this is a crucial one. What is cyclic permutation? So normally, if you have three vectors A, B and C, you'll place them as such, A, B and C. And if it's given as A cross B, C, so you're going from A, B, C, then create an arrow as such, A, B, C. You're going from A to B to C. And also just to complete the circle, go from C to A. Now, this tells you about the cyclic permutation. What do I mean by that? So, you see over here it says A cross B dot C is equal to A dot B cross C. Why? It's not just shifting. As long as you're moving in this direction, as you will see over here, as I'll come down, as long as you're moving in the direction in which the original cycle was, your scalar dot products are going to stay equal. There's been no negative sign. Okay? But if you move in the opposite direction, then it will come with a negative sign. Over here, see, you have A dot B cross C in this direction. You start here, go to B, go to C. So you're moving in this direction. That is equal to B dot C cross A. Why? Then it just means that you're starting here, going to C, then going to A. You're still moving in that same direction. Then you have C dot A cross B. That means you're just starting here, but you're going from C, A, B, C, A, B. As long as you're moving in the direction in which the original was, you will have them as all being equal. That is why you see the scalar triple product here. ABC is equal to BCA is equal to CAB. Why? Because originally ABC, you write A, B, C, create your direction of the cycle. That is equal to BCA because B, C, A, still moving in that direction, is equal to CAB, CAB, still moving in that direction. But as soon as I make it BAC, then see, to go from B to A to C, you're moving in the opposite direction. That is why it will come with a negative sign. Similarly, CBA, you're going from C to B to A, you're moving in the opposite direction. That is why it's negative of all of these. Similarly, when you go ACB, moving opposite. So, as soon as you've been given any scalar triple product, write them down and see how they connect. A to B to C, right? You get the connection, get the cycle, then see the other forms. Are they in the same direction of the cycle or are they reversed? If they are reversed, then they will each come with a negative sign. Okay? Moving on, we have one example here. We need to find the volume of a parallelepiped whose coterminous edges are I cap minus J cap plus K cap, 2I cap plus 3J cap minus K cap, and minus I minus J plus 5. So we'll create the determinant out. It will be 1, minus 1 and 1 for this. You have 2, 3 and minus 1, and this is going to give you minus 1 and 5, right? So over here we have 1 into 3 into 5, 3 into 5 minus 1 into minus 1, which is just going to give us 1, and then over here we have minus 1 into minus of minus 1, which will make it plus 1, into 2 into 5 minus of minus 1 into minus 1, which is again going to give me plus 1, so minus of plus 1, and over here I have again 1 into 2 into minus 1, that makes it minus 2, and minus 1 into minus 3, which makes it plus 3. Minus of minus 3 makes it plus 3. So this gives me 15 minus 1, 14. This gives me 10 minus 1, 9. and over here I have just 1. So that is 24 units. So 24 unit cube. That would be the volume of this parallelepiped with these 3 vectors given here. Okay, so that is how you solve questions on scalar triple product. The key thing here is to remember this cyclic permutation, because that will define whether it will be positive or negative. That's it with regards to this session. Thank you so much for watching. I'll catch you all in the next session.